Hello and welcome to Breadboarding channel. Today I'll be breadboarding and playing with Tube Screamer. And no need for a long introduction, I suppose. Probably one of the most copied pedal out there. Probably every single manufacturer has a version of it. You know, if you look at it, Ibanez itself has many versions of it. I happen to have this TS9DX, but you know, Super Overdrive as the one, Boss's Super Overdrive, practically the same circuit, slight difference in sound, but very similar. Overdrive OD1 just doesn't have tone knob, but very similar to this. And you have like something MXR, even Zakk Wylde's signature one. So I'll focus on this TS808, the original Tube Screamer, and you know, players mostly associated with it, Stevie Ray Vaughan, Gary Moore, you know, John Mayer, they lean to this bluesy side. It's great for blues, right? But if you look at the Tube Screamer and its derivatives, you have them everywhere, you know, in rock, heavy metal, even metalcore. Bands like Bullet for My Valentine, for example, use it. Tube Screamer or Zakk Wylde's version of MXR, and you know, players like Slash, Kirk Hammett, you know, you pretty much have I could go on with names for the rest of the video, you know. If you just look at what you have there, how many derivatives there are, you can just go and check it out, you know, online, and you have, for example, on Sweetwater, 27 Tube Screamer style pedals compared. Which is right for you? I mean, of course, these are not all. They're similar circuits with their own twist to it. You know, you go down and there's really, I think I counted. It's not 27. They're at least on this page, but this is only looking into Tube Screamer kind of address. It doesn't even look into SD1 and likes, you know. So let's see. I mean, let me now do some actual work, you know. I'll do a breadboarding of the pedal, but I'll do it slightly differently. Let's see what I have here prepared. So what I'm going to do is I'm going to use this schematic, and as always, you have them on my website, all of the schematic and stuff. This time, what I'm going to do, I'm going to go and, oops, I'm going to do this bit by bit, section by section. So I have power supply section here. I'm going to do that first, obviously. For whatever I do, I'll need that. But then I'm going to go and do input buffer and output buffer and just show how that works. Now, once I've done that, I'll go to this gain and clipping section and then go to tone and volume section just to see how everything fits together. It's going to be interesting. I did adapt circuit a bit, just very tiny, no difference at all. I just used components I had handy, so that's what's reflected on this schematic. So let me see. I have it here. So let's look at the first section. So I'll do the input and output buffer. So here I have input buffer, and first time around I'm gonna breadboard both, and then I'm gonna play with input buffer, output buffer, and we'll see where that goes. So let me get to it. All right, that is done. Well, actually, I forgot this. Just realized it won't work without this. And one more thing that I realized is, if you're gonna do this, don't do it bottom up, do it top down. Just it's easier to do the bits further away from you than the ones once you start working from here. It doesn't really matter. So what we have here is input and output buffer. So I haven't connected actually. So what I'm going to do is, instead of doing this first bit here, this upper part here is the input buffer. So I'm just gonna connect. Actually, I deliberately, this is not part of that same input buffer. It's decoupling capacitor for the next stage, but I just included it here so I can actually get the sound out of just the first input buffer. This is interesting. It won't work if I don't plug things in. Let me just plug things in. Okay. Oh, power. Let's see if this is going to work. Hey. And as you expect, it's quite it's not loud, it's quiet, because obviously there's no what you call it, there isn't any gain here stage. So let me just wire the switch real quick, and we can hear, you know, when we do these things. I'm just gonna let me turn off my amp first. Just gonna do this real quick so I can press. I can flip the switch, and then we can see what's happening. You know, just gonna bypass here. It's real quick. I can see where. Okay. Okay. Hopefully you can see this switch is just bypassing the effect. So. All right, no difference, and you would expect that because of the fact that these are just buffers. So let me just go and rewire it here. You see this yellow one. So what I'm just going to actually put this to the actual output. I'm just gonna wire in, and I'll just remove this one. This is not part of that. I'm gonna wire in here. So No difference. No difference. And the idea here is what I did here. Let me just turn off this for a sec. So what I did here, I just wired it up as what the pedal would be in bypassed mode. So if you remember Tube Screamer originally, it doesn't have true bypass, it has this buffered bypass, and this is actually that buffered bypass when the effect is disengaged, so it's never actually off. So you can try it out if you put your pedal, if you plug it in, and with the true bypass, even if the pedal is disconnected, you'll get some sound, you know, at least dry sound from the guitar. But Tube Screamer won't work without being powered up, you know. So that's really it. So let's move on to the next stage, and this is, I mean, this is getting a bit more complicated. I'm gonna go and do now clipping stage. I used any 5532 for this. You won't be able to tell the difference by just looking at the chip without looking at the marking on it, but it doesn't really matter. If you think about whether the op amp used makes a difference, you know, there's various school of thought. If you go and look at some of the YouTube videos there, where people actually do try these out, you know, you have Meatbuster here with op amps, and they go in and do track.
I've got
you know,
two pedals. Not going to tell you what the two pedals are, but I've got two pedals here. They're overdrives, I'll tell you that much.
Yeah, so you can go and watch that. Essentially they play. He goes on and replaces several op amps. There shouldn't be a huge difference. If you think about it, what makes a big difference is your capacitors. Some of them, for example, these film capacitors. This one I think has 10% tolerance. This blue one here, I think it's 5. I don't know. These electrolytic capacitors, they have 20%. Your pots have 20%. So when we talk about it, you know, you're talking about your Tube Screamer, the parts that make a difference, like the capacitors that actually define the output, the response, frequency response, the most, they can have 10-20% tolerance. Your distortion can have 20% tolerance. Your capacitors that deal with tone control can have 10-20%. So the question is, what would make a bigger difference in that case? So op amp should not make a difference. Okay, so we'll see. Almost any dual op amp will work. I have 3 handy, so I'll give it a try with 3 different ones. But let me breadboard the second part, and let's see how that sounds. I wired up everything, I think. This time I did it top down, made huge difference. I wired this up only the clipping section. So if you look at here, it just kind of I have input buffer here going through the coupling capacitor to the first op amp, and then the clipping happens on the with the diodes. For example, SD1 has a symmetric clipping here, has two diodes here and one this in this direction, and then it's a bit larger distortion pot, so it has more gain. And then I wire this up back to output buffer. So the main difference now is that we have this clipping section. Let me just put this all the way down. Let's turn on the amp. And battery. All right, so embarrassingly, I forgot this connection here. So without having a proper reference value, this won't work. And it kind of parts out if you dig into the strings, so it's kind of a bit embarrassing now. But on a positive side, you want to figure this out while you're breadboarding, not when you have everything soldered. So, bypassed. Turn it on. And you can see immediately. It's way louder. So when the pot is all the way down, actually the amplification, the gain is 10, so it's nearly 20 dB actually. So that's why you hear the difference. So let me just see. This should be working now. It's very shrill, isn't it? So to remedy that, let's go to the next step. And this is to complete the pedal, we need to add tone control here. So I'll do just that now. I believe that's it. So everything is completed. I have volume here, tone here. I'll put this somewhere in the middle. And let's see what we get. Turn this on. Way nicer already. Okay, and the reason for this is we added some, let me see if I have this here, right. So in the tone section, there is this filter that, low pass filter that filters out some of the higher frequencies, and then the tone control is, let's see how it is set. It's all the way up. And if I go all the way down, you can see it's softer, less loud, so way quieter. So definitely there is a bit of definitely difference. Volume, you know, I can control the volume working. But one thing to note here, I wanted to just say this. This is linear pot, and it's I had 25K instead of 20. The original taper is not linear. It's slightly different. So let me just show this. So taper is let me show this on the. This is from Born's pot datasheet. So B is here. Let me just go to the. Okay, I colored it a bit. So B, normal B, is just this, your linear, this curve. So it linearly goes from 0 to maximum as you rotate the pot. Now, that's not great for this type of tone control. And in Tube Screamer, you have this B4 or let's say G or WS. Like it has different marking depending on the manufacturer. But like it's 4B, for example, here for Borns, and you can see how steep it is in the ends of. So when you start at the very beginning, at the first 20-30%, it goes slowly, you see here, and then when between 30 and 70%, it goes very quickly, and then it slows down at the very end. And let me just give you an example from Alp's datasheet, and it has this interestingly. It's saying that 3B here is for volume control. So it's not. Yeah, I just wonder how do they if in some of the equipment you would use this 3B taper instead of logarithmic taper, which is here. See, I wonder. But if you observe here, 3B here and 3B here are not exactly the same. So this one starts from 20 and it's like 5% here, 20. Maybe it is. It is kind of a, maybe this is just a better plot here. So, but I would, always check datasheet if you. Now it's a bit awkward because this one is not that, and I don't know if you can see here. So it's a bit crappy choice of colors, but you can see how G taper or this 4B spreads out the tone control, and then here you see how with linear is squashed, completely squashed. So if you use for B, at that first part that there is a big jump here, it kind of slows down and makes this part more controlled, and you can see here more controlled, and then middle is definitely better controlled that way, because otherwise it is squashed. So that's something interesting. I thought that linear, while doesn't make the change to the sound, it just makes the control better. So I've put in any 5532, as I said before, and I was kind of saying it shouldn't make a difference what op amp you put in. So I have 3 different ones here. I have 2 BJTs and 1 JFET op amp. So let me just do a quick demonstration with that to see what kind of a sound do we hear. Let me just. Okay. Okay, so let me just put in what I have here. LM358. I got it from somewhere at some stage. So let's put it in place and see how that sounds. Making sure that pinout is right. Orientation of the op amp. Going there. Okay, it's in place. Let's hear it. It's way quieter. And that's because I didn't engage it. So, okay, let's hear it. Oh, it's very fizzly, isn't it? Yeah. And straight away, it sounds differently, and I have the gain it halfway up, so it shouldn't be clipping that much. It will be clipping, as you've heard. It does clip, but LM358, I don't like it. And just tells you that you can't just put just any op amp in. Now, having said that, most decent ones and those ones that are commonly used for pedal building will work. So this TL072 Venerable One used nearly everywhere. For DIY, let's try that out. This time it's engaged. Okay, that sounds pretty much the same as any 5532, I think. I'll have to re-listen the recording and make up my mind, but it comes down really to some of the characteristics of op amp, I suppose, but it most should not make any differences. You can see in this one example, but it comes down to biasing requirements, and probably the other one would sound the same with slight adjustment of the biasing. Now it's important to tell that, you know, LM358 has different input impedance, different other characteristics. That the fact that it's BJT is probably where the similarity ends with any 5532. So something to be careful of. But like I'd say, any common op amp will do. That's commonly used in pedals. So that's it for today. Next time, what I'm going to do is I'm going to try to get rid of these, to do a minimal version of this pedal. So because of because BJT has lower input impedance, and it's kind of it requires this input buffer for to preserve the fidelity of the input signal of the guitar. Also, output buffer not strictly necessary, but keep in mind that Tube Screamer doesn't have true bypass, so I suppose that's where this comes from. Essentially, if we used something like TL072, we could get rid of these bypasses, these buffers, and we use true bypass, and then we get a minimal version. But it is tempting to. I wonder, I have the pedal here, so next time I'm just gonna make sure that we actually get that what I'm showing here is actually matching what's on this pedal. It is going to be a slightly different. The circuit in TS9 is slightly different, but it's really minimal difference, and we'll see how this compares to it and how the minimal version compares to the actual pedal. Until next time.